Hello everyone. Today I'm going to present a work called Multiview Tracking using weakly supervised human motion prediction. Most recent approach in tracking follow the tracking by detection paradigm. First, they detect people in individual frame. Then, they associate those detections over time to form track and assign to them a unique ID. One problem with such approaches is that they heavily rely on the detection. If some detections are missed, for example due to self-occlusion, it can cause problems during the association phase and cause identity switches. Additionally, since the detections are extracted frame by frame, they ignore prior about human motion and temporal information. To overcome those limitations, we propose to predict motion instead of detection. Given a pair of consecutive frames, our model directly outputs the flow of people between those two time steps. Additionally, we work in a multi-view setup. It helps with occlusion, and the alignment between views is obtained with a top view reprojection. The added benefit of such reprojection is that for people anywhere in the scene, their speed and motion length is uniform. We predict the flow f between pairs of consecutive frames. The human flow is represented as follows. First, we discretize the ground plane into a grid. For each cell in that grid, we predict 9 probability. 8 of those probability represent the probability of motion toward one of its neighbors, and the last one is the probability to stay at the same location. If all of those 9 probability are 0, it means that no one was at this location to start with and no one is moving. Using this representation is beneficial in many ways. First, it allows for easy reconstruction of detection at the start and at the end of the motion simply by summing over the flow. This reconstruction step is easily differentiable, which allows us to supervise our training using detection supervision only. Secondly, it naturally embeds motion prior, since people cannot randomly appear or disappear. Finally, temporal consistency between consecutive flow can be easily enforced. Here we show our full motion prediction model. It takes pair of multi-view input. It extracts features separately for each view and time step before projecting the feature into the common ground plane. After that, those features are temporally and spatially aggregated to generate the human flow between the time steps. From this flow, detection at both time steps are reconstructed, which allow us to predict motion without the need of expensive identity annotation. Association algorithms such as KSP or MuSSP reconstruct track from detection using a graph representation and running a max flow min cut optimization. We propose to modify them to leverage the predicted motion by using the flow to compute the graph hedge costs. Using those enhanced association algorithm, we obtain state-of-the-art result on the multi-view tracking dataset WILDTRACK. To conclude, we propose to predict human flow in a weakly supervised manner and leverage it to improve tracking. Our code is publicly available. Check out our paper for more information and come talk to us at our poster session.